Now in this session we will discuss how a fixed half of a mold base is converted to the fixed half of a mold. Now we have this plastic component that is molding. You can see that this is the plastic component that is the molding. For this we will create a mold, two impression mold, that is two cavity mold. That is two cavity mold. Now other features of the mold would be that it will have a edge gating or rectangular gating, edge gating. It will have pin ejection. It will have round runners, and the round runners will be cut in both halves. That is, one semicircle will be cut in the cavity plate and the other semicircle will be cut in the core plate. So the parting line of this will be here. This will be the parting line. This will be the parting line. So now with these features in mind, we will convert the mold base, that is the fixed half of mold base, into the fixed half of mold. Now you can see that this is the cavity plate. This is the cavity plate. Pillars are coming out. These are the pillars. This is the pillar diameter, which will go into the guide bush ID. And this here, there is nothing. There is no cavity and there is no cooling hole, etc. So now we will convert this cavity plate into the cavity plate of the mold. Now you can see that this is the cavity plate of the mold. Cavity plate of the mold. This pocket is cut, and this is a through pocket. This is a through pocket. This is a through pocket. Otherwise, everything is same on the face. Besides this, there are two through holes have been drilled. This is the one drilled through hole, and this is the another one. These through holes are tapped here on the start so that a nipple can be inserted. These are the cooling holes. Now this is the nipple, water nipple. This is the water nipple. It will be inserted here, and a hose pipe will come, and the water will go through the hose pipe, through the nipple and into the cavity plate. It will come out from the other end. This is a through hole. I will show you. So the water will enter here. It will come out here. Similarly, in the second one, the water will enter here and it will come out here. This is the best option. Otherwise, we can also create another option, that is the water which is coming out here, it can go here. That is, this will become the inlet, and this will become the outlet. So these two ports can be connected, and this becomes the inlet and this is the outlet. But this is not preferable, because in that case the warm water will enter here and it will leave still warmer. So the first option, that is the water enters here, leaves here, water enters here, leaves here. It is a better option and it will give a better cooling. So now I will show you that these holes are through holes. So I will insert a kind of a rod here, and you can see that this is a through hole. This is a through hole. Now these through holes are drilled. They are machined through by drilling. They are drilled. They are drilled holes. So by creating a pocket and these two cooling holes, the cavity plate of the mold base is converted into the cavity plate of the mold. Now I will show you how the cavity is created. Now this is the only pocket. This is the only pocket. It will receive the cavity inserts and a bridge piece. You have already seen the cavity. This is the cavity insert. This is the cavity insert. Yellow portion is cavity. Yellow portion is cavity. And the whole block is called a cavity insert. What is a cavity? Cavity creates the outer shape of the molding, outer surface of the molding. And the insert, cavity insert, contains the cavity. So this whole thing is cavity insert and it contains the cavity. That yellow portion is cavity. Now here you can see it contains the runner channel. This is the you can see that this is the runner, this is the runner, this is the runner channel, and at the end here a very small passage which is known as the gate. So the material will come through the runner and it will enter into the impression through the gate. Now we will assemble it, or we will locate it rather, into the pocket. Now you can see it has gone into the pocket. Now one thing more, see, this is a cavity insert. It contains 4 tapped holes. Now here is 1, 2, 3 and 4. They are 4 tapped holes. These tapped holes are created so that it could be retained into the pocket. It does not have any shoulder. So when the cavity insert or any insert does not have a shoulder, it has to have a tapped holes for retaining. So now I will insert the second one into the pocket. It has gone. Now this is the bridge piece. It will come in between the two inserts. Now you can see that this is a hole through which the sprue bush will come. Sprue bush will come. Now this is the sprue bush. This is the sprue bush. This is the sprue bush. This is a spherical radius. This is the spherical radius. Yellow portion is a spherical radius, and the nozzle will come and will sit here. And there is a hole in the nozzle which will align with this hole, and the plastic material from the nozzle will go into the sprue bush. So the material will enter from here and it will come out from here, come out from here. You can see this hole is bigger in diameter. You can see this hole is bigger in diameter and this hole is smaller in diameter. So this hole inside the sprue bush is a tapered hole, and this tapered hole is created so that the sprue comes out easily. When it is pulled, it comes out easily. And now you can also see that this end has got a runner channel as well. This is the runner channel. So the material will come out from this hole. It will travel through this runner channel, and this runner channel will align with the runner channel in the bridge piece. So you will see it, like I will assemble it. Now I insert this sprue bush. Now you can see that yellow portion is sprue bush. Yellow portion is sprue bush, and there is a runner channel in the bridge piece. This is the runner channel. This is the runner channel. This is the runner channel in the bridge piece, and this is the runner channel in the sprue bush. So the runner channel of the sprue bush aligns with the runner channel of the bridge piece, and the material will come out from this hole. It will travel through this runner channel. So now you can see if the sprue bush rotates, then this alignment of the runner channel in the sprue bush and the runner channel in the bridge piece, they will not be aligned. The alignment will be disturbed. So the sprue is prevented from rotation through a pin that you will see when the assembly is done. Correct? So you will see it when the assembly is done. Correct? So, and this runner channel in the bridge piece, this will align with the runner channel in the cavity insert. With the runner channel in the cavity insert. So the material will come from this hole. It will travel through the runner channel in the sprue bush. It will travel through the runner channel in the bridge piece, and it will travel through the runner channel in the cavity insert, and through the gate it will enter into the impression. So now I will assemble this bridge piece. Yes. So as I told you that the cavity insert has got the tapped hole, and this is the socket head cap screw. This is the socket head cap screw. It will come through the front plate and it will tighten into the cavity insert, correct? And as well as in the bridge piece. Bridge piece also will be retained through the socket head cap screw, which will come through the front plate, and it will be the cavity inserts and the bridge piece will be retained into the pocket. Now the tolerance on the pocket width, that is, this is the width. Here it is H7. Here it is H7. Here also the lengthwise also the tolerance is H7, capital H7. Now these inserts has got the tolerance of K6 on the width, and the length is maintained in the assembly. Length is maintained in the assembly. Now we, as I told you, this H7 K6 H7 K6 is a transition fit. It could be a clearance fit, it could be a interference fit. But we machine the the dimensions in such a way that we obtain a clearance fit, so that the inserts go easily, because it facilitates the assembly. Now you can see that both the cavity inserts and the bridge piece, they have gone into the pocket. So now in the next session we will assemble the cavity plate with the front plate, and the fixed half of the mold will be completed. So this is how the mold base, fixed half of the mold base is converted into the mold. It's a very simple to understand, nothing very difficult. Thank you.